In this video, I want you to see that you can separate everything into a lot of interface files and have interface files import each other to really have a big project. We will take the same project we had before and break it into two interfaces. We will have a math stuff interface that we always had, but we will also have a print interface, which is going to have a print related functions in our program here. Let's show you the interface file for math. It is going to have the add function and the point class. This is the interface we have. Notice the module declaration. It is the most important thing if you ask me. Make sure you see the global module fragment, the module preamble, and the module purview. These are words you need to be able to understand to communicate using C++ 20 modules, to talk to other developers and express your ideas. And we have the print interface file. Notice it is a new interface that we are introducing because we have the declaration here, export module print. Don't forget the semicolon here. And it is going to export the two methods that we have here, greet and print name length. And we can set up implementations for these interfaces. The file we have here is the implementation for the math staff interface. That's what we are saying here. It is going to import the other interface. It is going to import the other module that we just defined. Isn't this cool? And it is going to use it by calling the greet function here. And this is going to fall in place and work. Let's look at the implementation for the print interface. It is right here. Again, it has two functions, greet and print name length, and it is going to work. Notice that the includes are showing up in the global module fragment. This is a practice you should follow. You shouldn't have any preprocessor related stuff anywhere else. You should put all that in the global module fragment, and your code is going to work if you happen to need this. This is really all we are up against in this video. Let's head over to our IDE and see this in action. Okay, here we are inside our Microsoft Visual Studio IDE. I created the project and we need to go back to the repository and see the files that we have to deal with here. Now we have the main CPP file, the math interface file, the print interface file, and the two implementation files because we are breaking everything in two interfaces, the math interface and the print interface. Our project is made up of these files that you see here. Again, it is a repetition of what we have seen. We have instructions to compile using the Visual C++ compiler. You can see them right here. And these are the instructions to compile using the GCC and Clang compilers. Notice the order we compile things in. Again, we will start by the header unit. We will compile the interfaces, and we will compile implementations that depend on these interfaces. And after that, we will put everything together to create our rooster binary. The same ideas apply. IO stream, the math interface, the print interface. We put everything together to create the implementation files. You can see them right here. And we build our object files and put everything together to have a final binary that we can run. Let's do this inside Microsoft Visual Studio. The first thing we need to do is to create the files. So let's add our interface files. So the first one is going to be math.ixx. The second one is going to be math. The second one is going to be print.ixx, the interface file. So let's do that, print.ixx. And we will add the implementation files. So let's look at the names to make sure I don't mess up here. We have math.impl and print.impl. Let's do that. So add, it's a CPP file, a C++ file, math_impl. This is the naming convention we have chosen. And we have to add print.impl. So let's do that. Add new item, a C++ file, print_impl. And we have to add this. And the rest is really copying code from the GitHub repository and using that in our project. We start by the math interface. Let's copy row. And it should say copied. Let's go to the math interface file. Why don't we have any content predefined in here? Let's see how this is going to go. The math interface file is in. It is a module file, so we have, it is a module interface file, so we have to export module and say the name of the module. Let's do the other module, print.ixx. It is really simple. copy it, and come back to our code, print, delete everything we have in here, and put in our module. Again, export module because this is a module interface file. Let's go to math impl, and we copy everything and come back to our IDE, math impl. Let's delete everything we haven't put in, the new content, and we need to go to print impl. Let's copy this and come back to our IDE and do print underscore impl. And the rest is really doing the main file, which is going to put everything together. Copy everything and come back to our IDE and go in the main CPP file. We take out whatever it is we had before and we paste in the new content. Okay, now that we have done this, remember this is a C++ 20 modules project. We have to enable C++ 20 in this IDE that we are using here. Let's go to language and use C++ 20. We have to go to general and enable scan sources for module dependencies. This is needed for our code to work. Apply, okay, and we can try to build. Let's hit the build button here. And the build is going to be good. Congratulations, you have made it. Again, try to learn from this IDE. It is going to scan the dependencies. It is going to find a few files. And after it has the dependencies, it is going to compile in a specific order. Notice that it is going to compile the print interface first. Remember that the math module is going to be using this print interface. So we compile it. We compile IO stream, the header unit. We compile our implementations. We compile math, and we compile main CPP and math impl. This is the order you can follow to compile these things. Now that you have seen how we use this using the compiler and IDE from Microsoft, the next step is going to be using the other compilers that we have access to. This is going to be a repetitive process. I do encourage you watch it, but if you don't want, you can move on to the next lecture because we are not going to be learning anything new. We will be just using these commands on the terminal, but I strongly recommend you try these things out. Compiling things on the terminal is something you may do in your career as a C++ developer. Let's copy the command for GCC. And I need to go to PowerShell inside our IDE here. So let's go to View Terminal. I will have PowerShell here. Let's do ls. It is going to show me the main files in our project. Again, what we care about is this set of files. The rest here is the noise from Microsoft Visual Studio. We don't really care about that. Let's run the command to compile our header unit. It is going to go through. Let's compile our interface, the math interface file, put in the command. We grab the command to compile the print interface and put it in place. We grab the command to compile the implementation file for the math module. Let's make sure we grab it correctly because I don't want any typos here. And you don't have to memorize these commands. Make sure you have them somewhere so that you can copy from them. What I do in this chapter is really what I do in my career when I am working on projects. You can find me browsing through my repositories, hunting for commands that I can edit because I am really bad at remembering these commands. I have better uses for my time. Now we have the rooster binary generated. If we run it, it is going to do what we need to do. And we have just used the G++ compiler to compile this project that is using functionality spread across modules. And this is really cool. Let's clean up the mess left by GCC so we can remove any object files. We can remove rooster and we can remove the GCM folder recursively, GCM, and it is going to go away. If we do ls, we are clean again. Let's go to the command prompt and use the Clang compiler. So again, we use the command prompt because PowerShell has given us problems earlier. We don't want those problems, but the command prompt can work. Compile the IO stream header unit, put it in place. We copy the command to compile the module file and put it in place. We copy the command to compile the implementation file for math. You see, it's a really long command. I don't think I had a chance to explain these things to you, but when you compile with Clang, sometimes you have to specify the location of the PCM files, and you do that through this flag here. If you are confused by Clang, you can go to your search engine and say Clang C++ 20 modules in the search engine, and you should have an entry that shows you the documentation for using Clang. I want to try to explain this because this changes across Clang version, and I can't really do a better job than what they are doing here. So make sure you read this if you care about Clang. What I am showing you is just the result of me going through this documentation and adapting the commands that they give here to work with the projects that we have in our course here. So this is something you can do if you are interested. Let's go back and compile. This is going to give us the implementation file. Print PCM not found. Why is that? Why is that? I may have lost my train of thought here. Print PCM. We didn't compile it. So let's compile print PCM first before we attempt to do this. Okay, let's grab it and compile it. So print PCM, now it should be available. Let's go down and compile the other one, which is going to be the math implementation file. And put in the command. This can be a tedious process, and if you come across errors, you're going to be pulling a lot of your hair. That's why I gave you these commands here. Okay, so this is done. Let's go to the other command, and it is going to be compiling our main file into an object file. Let's do this. And we can go back to compile the math stuff object file. And we can grab the command to compile the print file into an object file. And we are finally at the end. We needed to compile to see our rooster binary. And if we put it in, hopefully it's going to work. And it seems that it worked. dir on the command prompt, we will see our rooster binary and we can run it. Okay, and it is going to give us the result that we expect. This is how you can compile this project using the Clang compiler on Windows. We can now look at how we can do the same using the Clang compiler that lives in my Docker image. Let's ls to see what we have. Let's remove the junk that was left in by Clang on Windows. Let's remove any PCM files, remove any object files, and remove rooster. And we should be clean now. And I will be copying all these commands one by one. Bear with me. This is a tedious process, but you have to do it to be able to understand how these things work. We compile our header unit. We compile the math stuff. We compile the math interface file into math_stuff.pcm. This is the command. You will get a warning here that you will ignore. Let's put in the command to compile the print PCM file. Let's grab the next command and put that in place. It is going to be compiling math impl. Let's put that in our PowerShell window, terminal window. And we can go back and grab the command to compile our print impl file. Bear with me, this may be boring, but it is how you learn, my friend. Let's put in the command. The command is going to be compiling math stuff here. So this is what we need to put in. Grab the command to compile your print PCM file into a print object file. This is what we are doing now. Put in the command, hit enter. And we need to do the last thing, which is going to put together everything to generate our rooster binary that we have been waiting for. We have our rooster binary, as you can see right here. Where is it? It is here. And if we run it, it is going to do what we want it to do. This is really all I wanted you to see in this lecture. I hope you found it useful. I am going to stop here and I will see you in the next one.